Okay, so last class we have finished about dryland agriculture, and I also said you the problem soils videos. So have you all seen these videos? Yeah, not. Have you checked out? Anyone? No one checked out? It's okay, no problem. That's your loss. Okay. So today we are going to start about statistics. So this is all about one classes I kept. Actually, if I take statistics, then it may take around 7 days, okay, to complete the whole statistics in a brief manner. So today I will just go in a summary and what are the points are important for exam. So I will just toss those points and I will make you understand. So what is the meaning of that thing? Okay. So let's start. So there is only one thing motivation for you, that keep patience. Okay, because so many people are lack of it. Okay, because everyone will tell that keep patience, but when the time will come, actual how will keep patience, so at that time will be trouble. Okay, so try to learn how to keep patience, because in exam it is the most important key to become very stable in the exam center, and also to attend all the questions, because see there are 120 questions and there are only 120 minutes in the exam. So if you will be disturbed or you will be out of your mind, then you may lose a lot of marks and you will not get the questions what is there in the screen. So be patient, go to the exam center, close your eyes, and for 5 minutes just forget everything and just focus on the paper. That's what you should do. Okay, nothing else. So let's start our today's class. So as you know, that statistics is quietly related to the math. Okay, quite related to math, and so many people used to fear the statistics, and I have seen friends during my UG. Lot of people from Andhra, they used to fear the statistics. I don't know why, but it's very easy. Okay, and if you'll just give some love, or you can show some love, then you can understand the statistics very easy. Okay, आप easily समझ सकते हैं statistics को, कोई इसमें कोई दिक्कत नहीं है, या इसमें कोई आइंस्टाइन वाला ऐसे कोई थ्योरी नहीं है, बहुत ही आसान है। अगर सिर्फ आपको मतलब थोड़ा वक्त देना है इसके लिए, और कुछ नहीं। और हमारे जो स्टैटिस्टिक्स में वो रियल स्टैटिस्टिक्स वाला प्रॉब्लम नहीं आता है। ठीक है, क्वेश्चन आता है और फंडामेंटल क्वेश्चन आता है, तो इसको आप अच्छे से याद मतलब अच्छे से कर पाएंगे। ठीक है, 2-3 क्वेश्चन आते हैं स्टैटिस्टिक्स के, तो आपका 12 मार्क का आएगा एग्जाम। ठीक है, 12 मार्क का आएगा, 12, या अगर 5 क्वेश्चन आया तो 20 मार्क का आ सकता है। ठीक है, तो ये बहुत ही इंपॉर्टेंट है स्टैटिस्टिक्स, मतलब मार्क फेचिंग है स्टैटिस्टिक्स। तो चलिए शुरू करते हैं। तो डेफिनेशन ये बोलता है कि इट इज द प्रिंसिपल्स एंड मेथड्स ऑफ डीलिंग, कलेक्शन, समराइजेशन, एनालिसिस एंड इंटरेक्शन ऑफ डाटा आर नोन एज स्टैटिस्टिक्स। तो स्टैटिस्टिक्स में द मोस्ट इंपॉर्टेंट थिंग इज डेटा। ओके, so this data you can get through many sources, like you can do survey, or you can get this thing from the online, or anything you can get. Okay, so for statistics we need data. Okay, so first process first is collection. Okay, you should collect the data. After that, after collecting, you have to make a summary of those data. Means you don't need all those random data, you need a summary. Means what is desired for you, you have to keep that. Then you have to analyze those data. Okay, you have to, based upon your hypothesis, you should analyze those data. And after that, you have to see what is the interaction in between those, among those data. Okay, so the main definition of statistics is, first is collection, then we summarize, analysis, and interaction of the data are known as statistics. Okay, so it's a great tool, and it can be used in any subject. You can take in genetics or entomology, or you can take data science, or you can take in engineer. Everywhere statistics application is there, and it is must, because in everywhere we have to collect the data and you have to analyze. Okay. The father of statistics in world or in area is RF itself. बहुत सारा principles दिए in statistics में, इसलिए इनको हम father बोलते हैं. And the father of Indian statistics is PC Mahalanobis. Okay, he is also a great statistician. And World Statistics Day is on October 20th, जो कि RF फिशर का जन्मदिन है. And National Statistics Day is 29 June, जो कि PC महालनोबिस का जन्मदिन है. तो ये दोनों आपको याद रखना, मतलब रखना है. अगर कभी पूछ ले, अगर not in JRF, it may ask in state exams. Okay, if you are preparing for any government exam, then this question may come. Okay. Then how we represent the data. Okay, after collection of the data, how we represent those data. So we can represent those data in diagrammatic, means we can show some diagrammatic, and we can represent graphical. Okay, हम ग्राफ में भी ऐसे रिप्रेजेंट कर सकते हैं, या डायग्रामेटिकली. ओके, ऐसे बार डायग्राम या पाई चार्ट करके हम इसको रिप्रेजेंट कर पाएंगे. तो डायग्रामेटिक देखा जाए तो सिंपल बार डायग्राम जो है, ठीक है, सिंपल बार जैसे हम मतलब पहले करते थे ना, ऐसे सिंपल बार डायग्राम. ओके, देन मल्टीपल बार डायग्राम जो कि कंटिन्यूअस होगा. ठीक है, ऐसे कंटिन्यूअस होगा, मल्टीपल. देन कंपोनेंट बार डायग्राम, मतलब बार डायग्राम में ऐसे कंपोनेंट करके जो एक होता है वो वाला. देन परसेंटेज बार डायग्राम, ये कंपोनेंट वाला ही होगा पर परसेंटेज में होगा. ठीक है. देन पाई चार्ट में ऐसे होता है 100 से कितना प्रोपोर्शन हुआ. ठीक है. देन पिक्टोग्राम, पिक्चर एंड स्टैटिस्टिकल मैप्स और कार्टोग्राम, इसे हम डायग्रामेटिकली रिप्रेजेंटेशन कर सकते हैं. देन और एक आता है कि ग्राफिकल रिप्रेजेंटेशन. ओके, हमारे जो पॉइंट्स होते हैं, लाइंस एंड कर्व्स होता है, उनका हम बोलते हैं ग्राफिकल रिप्रेजेंटेशन, जो कि ग्राफ में होता है. वहां पे एक एक्स एक्सिस एंड वाई एक्सिस होता है, और यहाँ पे हम जो शो करते हैं, जो डेटा को शो करते हैं, उसको हम बोलते हैं ग्राफिकल रिप्रेजेंटेशन. ठीक है. देन एक और होता है हिस्टोग्राम. ओके, एक होता है हिस्टोग्राम, जो कि व्हेन द डेटा आर क्लासिफाइड बेस्ड ऑन द क्लास इंटरवल्स. ओके, देखिए फॉर एग्जांपल आई हैव डेटा लाइक 5 to 10, 10 to 15, 15 to 20. okay, it's a continuous, not discrete. Okay, so discrete मतलब 5 to 10, 11 to 16 ऐसे होता है. ठीक है. तो यहाँ पे जो क्लास इंटरवल है, जो 5 to 10 मतलब 10 plus 5 divided by 2, तो कितना है 7.5. ठीक है. So when the data are classified based on the class intervals, it can be represented by a histogram. Okay, so histogram is just like a simple bar diagram with some minor difference. वहां पे क्या होता है कि we need to take the continuous data. Here we are taking the class intervals, means we are taking we can say like frequency. Okay, we are taking the frequency. Okay, you can see it is a suitable form to present a frequency distribution, and there is no gap between the bars since the classes are continuous. It must be continuous. Okay, there should not be any discrete values. Okay, so that's about histogram. ये जाएगा. So in frequency polygon, okay, that one is frequency polygon. The frequencies of the classes are plotted dots against the midpoints of each class. Means here what we'll do, यहाँ पे ग्राफ करेंगे और जो डॉट्स आएंगे, okay, यहाँ पे हम इससे कनेक्ट करेंगे. okay, तो उसको हम बोलेंगे फ्रीक्वेंसी पॉलीगॉन. फ्रीक्वेंसी कर्व किसको बोलेंगे, सेम कर्व डॉट ऐसे आएगा फॉर एग्जांपल. तो यहाँ पे स्मूथ कर्व किया जाएगा, स्मूथ कर्व. ओके, सो उसको हम बोलेंगे फ्रीक्वेंसी कर्व. ओके, एंड ऑगिव्स आर known as cumulative frequency curves, and there are two kinds of ogive. One is 1 is less than octave and the other is more than octave. So in octave also we need to do smooth curve and there will be two more curve. For example, जो एक frequency होता है हमारा क्लास इंटरवल होता है और एक फ्रीक्वेंसी होता है जो कि रिपीटेड होता है. फॉर एग्जांपल 5 10 7 टाइम. क्यूमुलेटिव फ्रीक्वेंसी क्या होता है, इसको अगर 5 है ये 5 होगा, देन यू नीड टू continuously add the value with the latter value of frequency and you need to write it. So यहाँ पे जो फ्रीक्वेंसी होगा वहां पे लेस वैल्यू होगा और ग्रेटर देन वैल्यू होगा, तो उसका जो रिप्रेजेंटेशन करेंगे वो उसको बोलेंगे हम ऑगिव. ठीक है, तो यू हैव टू रिमेंबर दिस थिंग्स बिकॉज दिस थिंग्स यू नीड टू आस्क इन एग्जाम्स. ठीक है, देन आता है हमारा ट्रांसफॉर्मेशन डाटा. वी कैन ट्रांसफॉर्म दोस डाटा इनटू सम अदर values. For example, I can do square root transformation. I can do square root transformation. So where I will use this transformation, it is applied for data consists a small whole number. So like 5, 6, 10, 12. So when I will get this whole numbers, there I can use square root transformation. Okay, you can see the example. Data obtained in counting rare events such as the number of infested plants in a plot. So if I count about the number of infested in the plot, so I will get whole number. For example, out of 10 plants, 5 got infected. 5 got infected. So like that, number of insects caught in traps means I can count those plants, count those insects, that is in whole number. So that is, so when these data will be transferred, so we will use square root transformation. What that? Then एक और होता है हमारा arc sine transformation. Okay, so where we will use arc sine transformation, there will be when there will be, it can be countable and also the data expressed as decimal fractions means in like 1.2, 3.3, 5.5. So when decimal value will come, there we can use the arc sine transformation. Okay, and also in percentage. Logarithmic transformation कहाँ यूज करेंगे? डेटा दैट आर होल नंबर एंड कवर वाइड रेंज ऑफ वैल्यूज. ठीक, आपको एक विस्तार रूप में देखने के लिए आपको एक जो दशा देगा उसका वहां पे हम logarithmic transformation यूज कर सकते हैं. फॉर एग्जांपल, नंबर ऑफ इंसेक्ट्स पर प्लॉट. ओके, एक प्लॉट में कितना इंसेक्ट्स है, मतलब पूरा का पूरा प्लॉट में कितना इंसेक्ट्स है. नंबर ऑफ एग मासेस पर प्लांट. ओके, एग मासेस मतलब बहुत ही ज्यादा होगा. ओके, वी कैन काउंट, बट एक प्लांट में कितना है. अगर मैं सिर्फ एक लीफ में पूछा होता है, पर्टिकुलर कर दिया मैंने. ठीक है, पूरा का पूरा प्लांट में काउंटेबल है और वाइड रेंज ऑफ वैल्यूज दे रहा है, मतलब पूरा का पूरा प्लांट में कितना है. ठीक है, तो वहां पे हम लॉगरिथमिक ट्रांसफॉर्मेशन यूज कर सकते हैं. और मेनली logarithmic curve या logarithmic transformation we are using for small changes, small changes. जहाँ पे छोटा छोटा चेंजेस होंगे वहां पे logarithmic transformation करने के लिए बहुत ही आसान है. And also we use log value for small things. ठीक है. Next is measures of average. Okay, measures of average. So you must be knowing about AM, GM, and HM. Yes or no? Everyone, you know about it or not? आपको पता है arithmetic mean, geometric mean, and harmonic mean. ठीक है, तो arithmetic mean मतलब क्या है? It is simply the mean of a variable is defined as the sum of the observations divided by the number of observations. For example, मेरे पास 5 ऑब्जर्वेशन है, इसका वैल्यू 5, 10, 2, 3 and 12. ठीक है. So if I want to take the average of those values, so what will I do? I will sum up all those values and number of observations. So I have 5 observations. So whatever the value will come, that will be my average or mean value. Okay. So arithmetic mean is of 3 types. One is mean, median and mode. ठीक है, तो mean तो आपको समझ में आ गया. Median मतलब it is the middlest value. Okay, median मतलब it is the middlest value. Mode मतलब it is the most frequently occurring value. Okay, it is the most frequently occurring value. So I have written here geometric mean. I have written here there is a mistake. Okay, so it is all about median. Okay, okay, that I'll change, no problem. Okay, so अगर आपके पास even and odd type of observation है, so there how you use the midleast value. odd का तो बहुत ही आसान है, n+1/2 th value. Okay, n+1 divided by 2 th, मतलब उस पोजीशन वैल्यू विल बी द मीडियन. ठीक है, अगर आपके पास और इवन है तो n/2 वैल्यू भी कर सकते हैं, और n+1 by 2 वैल्यू, तो ये दोनों आपके जाएंगे. ठीक है, देन हार्मोनिक सॉरी मोड मतलब मोस्ट फ्रिक्वेंटली जो आता है. ठीक है, फॉर एग्जांपल यहाँ पे आई विल गिव द एग्जांपल 2 5 5 6 6 5 10 7. तो यहाँ पे देखिए बहुत ज्यादा मोस्ट फ्रिक्वेंटली कौन सा हो रहा है, 5 वैल्यू, तो मोड क्या है 5. ठीक है, एम जीएम एंड एचएम. ओके, देखिए अरिथमेटिक मीन जो है वो ग्रेटर देन ज्योमेट्रिक मीन है एंड ग्रेटर देन टू हार्मोनिक मीन. ठीक है, तो अगर एचएम, अगर मैं अरिथमेटिक मीन को मतलब इनवर्सली करूं तो व्हाट विल आई गेट, हार्मोनिक मीन. ठीक है, सो दैट इज द रिलेशनशिप. एंड मीन मीडियन एंड मोड का रिलेशन क्या है, मीडियन माइनस मोड इज इक्वल टू 3 माइनस मीन माइनस मोड. ओके, so sometimes they need to ask this equation. Okay, so you should remember it. तो थोड़ा प्रॉपर्टीज के बारे में पढ़ लेते हैं. ठीक है, तो मीन मतलब नॉन एज ट्रू एवरेज. ओके, मीन का मतलब क्या है, इज नॉन एज ट्रू एवरेज. so sometimes they should ask which among the following arithmetic mean which is a true average, that is mean, and it is mostly affected by extreme value. For example, in my observations there are some values like 5 10, and one value is there 50, and one value is there 10. ठीक है, तो what is extreme value, this highest value will affect the average, yes or no, because it is not near to the others value. Okay, so it may get affected by extreme values, mostly affected by both change of origin and change of scale. So you should know what is change of origin. When there will be plus or minus, that will be called as a change of origin, and when there will be multiplication or divide, okay, that will call change of scale. Okay, understood? And mostly used for quantitative data. Okay, it is mostly used for quantitative data. Median matlab not affected by extreme value. I have told you median is the middleist value, and how to calculate for when the observations are odd and when the observations are even. And it is known as positional average, means we are taking the average based on the position. Then mode matlab, mode is the best average. If the question will come about true average, then you have to choose mean. When the question will come best average, then you have to choose of the option mode. Okay, understood? Then mode is the highest or most frequent data. Okay, and it is mostly used for qualitative data. And sometimes they should ask that in business, what is the arithmetic mean we are using mode type. Okay, and also in the shoe, while buying the shoe, or for shirt size or any size, if anything or height, so there we are using the mode. For example, in the class, okay, in the class the boys of different heights, okay, will be which arithmetic mean we'll use the mode, because most frequently the most frequent data, most frequent height like 5 feet 5 feet 5 feet, so there we will use the mode. Okay, then distribution. Okay, see why use the distribution and not the, okay, not the arithmetic mean. Sometimes see arithmetic mean will give you the only average data. Okay, and it will not tell you, okay, so how it is well distributed. Okay, so under distribution we will have a like normal distribution, binomial, and Poisson distribution. Okay, normal distribution, it is like bell shaped. Okay, it is bell shaped, and this part is equal to this part. Okay, this part is equal to this part, and it is minus infinity to plus infinity. Okay, this value is 0. So in binomial distribution, okay, and in under normal, mean is equal to median is equal to mode. Okay, three values are equal. Under binomial distribution, here the probability is only 2. Okay, P1 and sorry, P and Q. Okay, here we have only 2 probable. One is P and it can be successful or it can be failure. Okay, अगर टाइम होता तो डिटेल में थोड़ा जाते हैं इनके बारे में. सो एंड why it is mean is less than variance also we could have discuss about it. Okay, no problem. अगर आपको इंटरेस्टेड है तो जब JRF क्लास शुरू होगा, okay, after exam then you can join the classes, no problem. Then Poisson distribution में mean is equal to variance. Okay, यहाँ पे क्या होगा कि जो हमारा जो skewness and kurtosis का वैल्यू होगा, skewness and kurtosis का वैल्यू होगा वहाँ पे सेम आ जाएगा. ठीक है, जो mean and variance का वैल्यू after putting the formula the same will become lambda and lambda. Okay, तो ये मतलब डिराइवेशन है, वो टाइम लगेगा, कोई बात नहीं. ये बस आप याद रखिए, पॉइजन में मीन इज इक्वल टू वेरिएंस, बाइनॉमियल में मीन इज लेस देन वेरिएंस, नॉर्मल में मीन इज इक्वल टू मीडियन इज इक्वल टू मोड. ओके, and most of the biological observations belong to normal distribution. Okay, you should remember this. This is a most important question. हमारे जो भी biological observations है वो इसके अंदर आते हैं, normal distribution के अंदर आता है. Then what is skewness and kurtosis? बहुत बार एग्जाम में आप देखे होंगे what is skewness and kurtosis. तो skewness का मतलब हम और why you use skewness means whether the data are symmetric or not. There we are using the skewness. मतलब जो मीन जो है वो जो मीन का जो अराउंड है whether that is symmetric or not, means you can see for example this is the mean, whether the data are symmetrically distributed or not, there we are using the skewness. And kurtosis where we are using whether the observations are normally distributed or not, means if there is any thickness or flattiness are there, we are using kurtosis. So it is of three types. One is leptokurtic, platykurtic and mesokurtic. I'll show you. Lepto means the beta will be more than 3. Okay, actually जो kurtosis का वैल्यू वो 0 to 3 है, रेंज है 0 to 3. तो बीटा जब more than 3 होगा then we call it as a leptokurtic, मतलब it will be higher value, thickness will be there. Platykurtic मतलब plate, okay, मतलब flat. Okay, so there the curve will be flat. Okay, mesokurtic matlab median. Okay, so in platykurtic it will be less than 3 and in mesokurtic beta will be equal to 3. This is all about skewness and kurtosis. You have to remember two things. Skewness matlab whether the data are symmetric or not, then we are using skewness. Whether the data are normally distributed or there is any thickness or flatness, there we are using kurtosis. सबको समझ में आया? Everyone?
Yes, sir.
Then है हमारा measures of dispersion. Okay, how the data has been distributed. Okay, so there we are using the dispersion. For example, in a sample, okay, after taking observation, okay, so average the arithmetic mean they will give the average values. Okay, for example, after taking in A block and B block, I got the average of 42 and 42. Okay, but I want the variance, means I want the variation, and I didn't get through the average value, measures of average that didn't show me. So, but when I'll do the standard deviation or anything measures of dispersion, then I can see what is the difference between these two blocks. Okay, so for that reason we are using the measures of dispersion. Okay, so there are various type of dispersion. So the simplest one is range. Okay, the simplest one is range. Question में आता है the simplest form of measures of dispersion is what? Range. Okay, so this is the simplest possible measures of dispersion and is defined as the difference between the largest and smallest value of the variable. And in symbol you can see highest value minus lowest value is range. Okay, ये भी आता है एग्जाम में, याद रखना. Then हमारा standard deviation, and you must have done on this the equations. It is defined as the positive square root of the arithmetic mean. Okay, positive square root of the arithmetic mean of the square of the deviation of the given observation from the arithmetic mean. Okay, and it is represented by the letter S. Okay, x minus mu by sigma. Okay, I is equal to 1 to n. Okay, this is the formula standard deviation. Okay, x minus mu square divided by sigma or number of observation. Okay, is equal to standard deviation. वेरिएंस मतलब इट इज द स्क्वायर ऑफ स्टैंडर्ड डेविएशन. ओके, ये भी बहुत बार क्वेश्चन में आता है. Then one term is coefficient of variance. Okay, coefficient of variance. See, in the standard deviation also, there may be some like equal values may come, or we may not catch up those. It will not show any difference. Okay, so in coefficient of variance, okay, when there will be a population of observation, or there will be a population in the block, so coefficient of variance, what it will describe, it will be describing the amount, okay, amount of variation in a population, and when standard deviation is expressed in percentage of mean. Okay, अगर दो population है, A population, B population, so उनके बीच में what is the variation, how and what is the amount of variation? If you want to know, there we will use the coefficient of variation. Okay, the CV, the formula is standard deviation divided by mean into 100. So this is the most important thing, and most of the time in exam it has been come. Okay, in field experiment, the CV should not be exceed 20%. You have to remember this. If you want to do research in the future, the CV value should not be exceed 20% in field experiment, and in lab experiment it should not exceed 5%. Most important thing. Okay. Then आता है हमारा standard error. Okay. See, when we do some experiment or anything, so we make some error. Okay, we make some error. So variability among the means of random sample. Okay, because we need to take some random sample in the field. Okay, we are not taking the like choosable sample. We need to take the sample random manner in the field, from the field. So variability among the means of the random sample is related to the variability of the parent population of the standard error. Okay, so from the parent population we will take the random samples, and we will take the mean of that sample. Okay, so variability among those means of random sample is related to the variability of the parent population by the standard error. So we are representing what is the error present in sample mean and also in the population mean. So it will just a representation. The standard error is equal to standard deviation divided by root over n. N matlab sample number. Okay, and the measure of precision, if you want to know measure of precision, how precise it's been, then 1 by standard error will give you the precision value. Okay, standard error of mean is a measure of sampling error. Okay, standard error of mean we are using for the measure of sampling error, and we are deciding standard deviation for a population and standard error of mean for a sample. Okay, where you are using standard deviation for a population and standard error of mean we are using for a sample. Okay, if the parent population we are calculating, then we are using standard deviation, and if we are after taking sample we are calculating the mean and we are relating, there you are using sample error of mean. Okay, this is one important question, where we are using standard error of mean and where we are using standard deviation. Understood? Then आता हमारा test of significance. Okay, test of significance. So this is one of the most important thing. Okay, सबसे थोड़ा important चलेगा हमारा test of significance. Okay, the statistical procedure for distinguishing or differentiating whether the observed differences are due to real sampling only or the mere difference is called test of significance. See, in the experiment, what is happening when there will be a block and there are lot of plants. Okay, so we need to take the random sample. I have given one treatment. Okay, so whatever the sample I have taken and whatever the differences I am observing in the field, whether that is due to this treatment or not. So for that, we are using the test of significance, whether our treatment effect is field or not. So that when we'll calculate, we'll call it as a test of significance. Then what is the test of hypothesis? So we need to take two hypotheses in any experiment. One is null hypothesis and one more is alternative hypothesis. For example, null hypothesis means says that there is no difference. When I look into the field, there is no difference. What will be the alternate? There is difference. Okay, there is a difference. So in any experiment, in any statistical procedure, we need to prove the null hypothesis. Okay, if there is no difference, then it is non-significant. If then there is a significant. Okay. So when the calculated value will be greater than the table value, okay, so it is the and we will accept the we will reject the null hypothesis, and if calculated value is less than table value, then we will accept the null hypothesis. Okay, when we reject it, so it is significant. When we'll accept the null hypothesis, then it is significant. Okay, when there will be calculated value is less than the table value, then we will to accept the null hypothesis, and it is the data will be significant difference. When calculated value will be greater than table value, I will reject the null hypothesis, and it will be non-significant. Okay, when there will be null hypothesis acceptance, okay, that will be okay. We'll accept the null hypothesis. It will be it will be non-significant, and it is significant. Okay, I told. So the statistical procedure for deciding whether to accept or reject the null hypothesis is known as testing the hypothesis. So there we are making two errors while accepting or rejecting the null hypothesis. For example, rejecting the null hypothesis when it is true. Okay, जब हमारा hypothesis true होगा and we will reject it, then we are making type 1 error. Okay, and when we are accepting the null hypothesis when it is false, okay, then we are making type 2 error. So each one will be more dangerous, type 2 one. Okay, because it is false and still we accepted it. So what will happen? It will be create some distortion in the data. So we are making type 2 error, and it is most dangerous one. So in exam, the question is to come, which error is most dangerous? Okay, type 1 or type 2. Okay, so you have to remember type 2 error is most dangerous because here we're accepting the null hypothesis when it is false. Okay. Then there are some tests, some like important terminologies we need to read. Okay, one is critical reason. Okay, one is critical reason. The testing of the statistical hypothesis involves the choice of a reason for the sampling distribution of statistics. If the statistics falls within this region, the null hypothesis is rejected. Otherwise, it is accepted. Okay, there will be a critical reason. Okay, we use it to calculate critical difference. Okay, so if the statistical fall within this region, then the null hypothesis is rejected. Otherwise, if it will be fall beyond the critical region, then we will accept it. Okay, so this region is called as critical region. Then level of significance. Okay, the probability that the statistics will fall in this critical region is called as level of significance. Okay, and it is denoted as alpha. Okay, this alpha is nothing but the probability of committing type 1 error, because when the data will or the statistic will fall within this region, what we'll do? We'll reject. Means when the null hypothesis will reject the null hypothesis when it is true. So we are committing type 1 error. Okay, we are committing type 1 error. So level of significance, it is nothing but the probability of committing type 1 error. So technically, the probability of committing a type 1 error is known as level of significance. Okay, and if you want to calculate the confidence limit, then we have to 1 minus alpha. 1 minus alpha. Okay, so whatever the error will be there, if you minus from the 1, then our confidence limit will be increased. Okay, not from the experiment. And 1 and 2 tail test, there will be two tests. One is one tail test and 2 tail test. Okay, based on normal distribution. The nature of the alternative hypothesis determines the position of the critical region. Okay, so alternative hypothesis kya bolte hai? There will be some difference. Okay, so based on that, the position of the critical region will be vary. For example, if h1 is mu1 is not equal to mu2, मतलब दो मीन जो है, अगर दो सैंपल है तो उनका जो मीन है वो सही नहीं है, मतलब इक्वल नहीं है. It does not show the direction and hence the critical region falls on either end of the sampling distribution. Okay, so when mu1 is not equal to mu2, so there will be the direction. It will not. It doesn't though. It does not show the direction and hence the critical region falls either end of, means यहाँ पे भी पढ़ सकता है या यहाँ पे भी पढ़ सकता है. And if it will be equal, it will be fall in the critical region. Okay, and if h1 is mu1 is less than mu2, मतलब mu1 is less than mu2 and mu1 or mu2, sorry, mu1 is greater than mu2, then the direction is no, means it can be right or it can be left. Not equality है, यहाँ पे direction नहीं दिखा रहे, तो it can fall in any region. Okay, and यहाँ पे अगर greater than or less than है, तो यहाँ पे direction आ जाता है कि यहाँ पे left side पड़ेगा या right side पड़ेगा. So in the first case, the critical region falls on the left of the distribution, whereas the second case it falls on the right side. मतलब ये first case है, ये second case है. Okay, first case में कहाँ पे पड़ेगा, ये less than है तो यहाँ पे left side में पड़ेगा, and यहाँ पे देखिए greater than है तो यहाँ पे right side में पड़ेगा. ठीक है. One tail test, when the critical region falls on one end of the sampling distribution, it is called as one tail test. Two tail test, when the critical region falls on either end of the sampling distribution, it is called two tail test. Okay, you have to remember this thing because when you'll go to the MSc first year, so this will be the question. Okay, and also in exam I have not seen from those part, so it's not about to worry, and it may come, so you have to remember that thing. Okay, then degree of freedom. Okay, degree of freedom means how freely the errors can be occurred. For example, I'm doing something, so I can commit one error. Yes or no? By knowingly or unknowingly, I can make some error. Okay, so to measure those errors is called as degrees of freedom. The number of degrees of freedom is the number of observations that are free to vary after certain restrictions have been placed on the data. Okay, so in an experiment, we always want to do some uniformity in the field. Okay, uniformity in the field. Still, there will be some variation. Still, there will be some variation. So, what up to what level these variations are free is called as degrees of freedom. Okay, you can see the degrees of freedom is the number of observations that are free to vary. Vary matlab kya hai? Variation. Okay, the degrees of the number of observations that are free to vary after certain restriction, means after applying all the restriction also there will be some variation in the field. Okay, that is called as degrees of freedom. The number of independent variables which make up the statistics is known as degrees of freedom. See, independent variables means like climate, soil, okay, and human error. So these are all independent variables. Means after you apply a uniform amount of fertilizers or uniform amount of water and everything is uniform, still there will be some variation. That is called as degrees of freedom. Okay. Then we have some large sample theory and small sample theory to calculate the and which test will be used for this thing. So when there will be more than 50 sample, we will use Z test. Okay. And when there will be less than 30 sample, we will use chi-square test, T test, and F test. Okay. Summarily, I will just consult tell last sample theory. When there will be more than 50 sample, you will use Z-test, and when there will be small sample, for example less than 30 sample, we will use TF or chi-square test. Okay. Then let's read about t-test, because so many times question may come. Question is coming from t-test. Okay. So first it was student t-test. Okay. पहले ये क्या था? स्टूडेंट टेस्ट था. ओके, इसको किसने दिया था? सर विलियम गोसेट ने दिया था. ओके, और इन्होंने उनका जो डिस्कवरी वो 1905 में अंडर पेन नेम स्टूडेंट बोल के ऐसे दे दिया था. मतलब एक पेपर पब्लिश किए थे और उनका नाम नहीं लिख के एक स्टूडेंट बोल दिए थे, बस स्टूडेंट. ठीक है. और ये किसका स्टूडेंट थे? प्रोफेसर आर एफ फिशर का स्टूडेंट थे. ठीक है. और स्टूडेंट टेस्ट ऐसे नाम देके ये छोड़ दी. सो टेस्ट के बारे में इन्होंने बताया था और नाम क्या था? स्टूडेंट. तो इसको नाम दे दिया स्टूडेंट टेस्ट. ओके. लेटर ऑन it was developed and extended by Professor R.A. Fisher, and he gave a test known as T-test. So first it was student test based on his student. Then R.A. Fisher ने इसको बढ़ाया, इसको extended किया और इसको नाम दिया T-test. So where we will use the application T-test to test the single mean in a single sample case, okay, or to test the equality of two means in a double sample case. Okay. टू केसेस यहाँ पे हो गया. वन इज वन सैंपल एंड वन इज टू सैंपल. अगर वन सैंपल में मीन को अगर टेस्ट करना है तो हम टी टेस्ट यूज कर सकते हैं, जो कि स्मॉल सैंपल लेस देन 30. अगर डबल सैंपल है और उनके जो मीन है वहां पे जो इक्वलिटी जानने के लिए हम यूज कर सकते हैं ये वाला इंडिपेंडेंट सैंपल. जहाँ पे इंडिपेंडेंट सैंपल होगा, मतलब देयर विल बी नो डिपेंडेंट सैंपल, वहां पे हम यूज कर सकते हैं टी टेस्ट. अगर डिपेंडेंट सैंपल है, there will use paired t-test. There will use paired t-test, and to test the significance of the observed correlation coefficient. ये भी बहुत बार आया एग्जाम में. ओके. एक correlation coefficient में वहां पे जो सिग्निफिकेंस क्या है उन दोनों में, जो ऑब्जर्वेशन में सिग्निफिकेंस टेस्ट करने के लिए ये वाला यूज किया जाता है. एंड टू टेस्ट द सिग्निफिकेंस ऑफ द ऑब्जर्व पार्शियल कोरिलेशन कोएफिशिएंट भी हम यूज करते हैं. And to test the significance of the observed regression coefficient, we are using the paired t-test. Okay. ये वाला जो है to test the significance of the observed correlation, you will use t-test also. We are using. Okay. देन आता है हमारा f-test. हमने छोड़ दिया है थोड़ा. ओके. f-test कहाँ पे यूज होता है? वेरिएंस जानने के लिए हम यूज करते हैं f-test. ओके. टू सैंपल वेरिएंस. देन chi-square test. ओके. So chi-square test is a non-parametric test. You should remember this. It is a non-parametric test. Okay. In the case of attributes, we cannot employ parametric tests such as F and T. So F, T, and Z test are parametric tests. Non-parametric test is chi-square test. Okay. You should remember this thing. Instead, we have to apply chi-square test. And where and when we use, when we want to test whether a set of observed values are in agreement with those expected on the basis of some theories or hypotheses. For example, we are reading so many things in the books, okay? Whether that is agreeing to the observed value or not, there we are using chi-square test, okay? Means, for example, I applied 100 kg nitrogen, okay? So I will expect that the yield will be very high, but whether that hypothesis is agreeing to actual observation or not, there we are using chi-square test. Okay. So it is used to test the independence of attributes, test the goodness of fit, test the homogeneity of variance में homogeneity है कि नहीं, test the homogeneity of correlation coefficients, test the equality of several proportions, and in genetics it is applied to detect linkage. Okay. Heritage and linkage. In that case, we are using the chi-square test. Understood, everyone? And it was given by Professor Carl Pearson, okay, in 1900. Okay, you should remember this. Then आता है हमारा correlation. Okay, so it was given by Pearson. Okay, the measure of degree of relationship between two continuous variables. Okay, there will be two continuous variable. उनके बीच जो रिलेशनशिप है उसको जानने के लिए हम यूज करते हैं कोरिलेशन कोएफिशिएंट. ओके. इट इज डिनोटेड बाय आर, ये भी पूछा जाता है। ओके, आर इज द सिंबल, ठीक है। फॉर एग्जाम्पल, और इनको जानने के लिए हम स्कैटर्ड डायग्राम का यूज करते हैं, स्कैटर्ड डायग्राम। ओके, इस तरह का होगा। अगर ऐसे बढ़ते हैं हो जाएगा तो मतलब ये पॉजिटिव कोरिलेशन, मतलब एक्स बढ़ेगा तो वाई बढ़ेगा। अगर एक्स बढ़ेगा तो वाई घटेगा तो उसका मतलब है नेगेटिव कोरिलेशन। एंड इफ देयर विल बी नो रिलेशनशिप बिटवीन एक्स एंड वाई, सो देयर विल बी रैंडम वैल्यूज, ऐसे स्कैटर्ड होके पड़ेंगे वैल्यूज। ओके, सो देयर इज no effect, there is no correlation between x and y. Okay, and what are the properties? Very important. The correlation coefficient value ranges from -1 to +1. Very important, most of the time it is, and it may also come in the exam this time. The correlation coefficient is not affected by change of origin or scale. यहाँ पे देखिए ना, यहाँ पे प्लस और माइनस है, ये यहाँ पे मतलब डिवाइड या मल्टीप्लीकेशन है, तो यहाँ पे दोनों का कोई भी इफेक्ट नहीं है कोरिलेशन कोएफिशिएंट। ये भी बहुत ही इंपॉर्टेंट है। इफ r is greater than 0, it denotes positive correlation. If r is less than 0, it denotes negative correlation. Okay, ये वाला बहुत इजी है। If r is equal to +1, मतलब एग्जैक्टली +1 है, तो इसका हम बोलेंगे परफेक्टली पॉजिटिव। अगर ये मतलब -1 है, देन इट्स कॉल्ड एज परफेक्टली नेगेटिव। देन आता है हमारा रिग्रेशन। ओके, तो रिग्रेशन क्या है? रिग्रेशन इज द फंक्शनल रिलेशनशिप बिटवीन टू वेरिएबल्स x एंड y। तो इनका फंक्शनल रिलेशन होगा, देखो a इज इक्वल टू a प्लस bx और ax प्लस b। ओके, of the two variable, one may represent cause and the other may represent the effect. So one will be the cause, one will be the effect. So y is the cause, x is the effect. For example, I applied 5 kg nitrogen, so x will be the yield. X will be the yield. So after applying 5 kg nitrogen, so what will be the yield? So when there will be cause and effect relationship will be studying. So there we are using a regression. Okay, the variable representing the cause is known as independent variable because this is not dependent and is denoted by x. Denoted by x. The variable x is also known as the predictor variable or repressor, means we are predicting the thing which is independent. The variable representing the effect is known as the dependent variable and is denoted by y because y will be dependent to the x. Okay, y will be dependent to the x variable. Okay, and y is also known as predicted variable. यहाँ पे predictor, यहाँ पे predicted. ठीक है, predictor बोल रहा है कि प्रेडिक्टर बोला कि जब मैं 5 kg नाइट्रोजन डालूंगा तो 10 kg मुझे रिटर्न मिलेगा। ओके, सो प्रेडिक्टर विल बी प्रेडिक्ट द थिंग। ठीक है, तो प्रेडिक्टर विल बी इंडिपेंडेंट एंड प्रेडिक्टर इज डिपेंडेंट। ठीक है, द रिलेशनशिप बिटवीन द डिपेंडेंट एंड द इंडिपेंडेंट वेरिएबल may be expressed as a function and such functional relation is called as regression. Okay, so x is equal to a y plus b हो सकता है या y is equal to ax plus b हो सकता है। ठीक है, दोनों पॉसिबल। The correlation coefficient is the geometric mean of, okay, geometric mean of two regression bx and by. Okay, bx and by. Okay, the correlation coefficient is the geometric mean of two regression coefficients. Okay, ये भी आपको याद रखने, बहुत बार पूछा गया एग्जाम। Regression coefficients are independent of change of origin but not change of scale because यहाँ पे multiplication हो रहा है। Okay, but positive and negative नहीं हो रहा है, so plus और minus नहीं हो रहा है, तो change of origin यहाँ पे काम नहीं कर रहा है, but sorry change of origin है, sorry change of origin नहीं है, change of scale है। ठीक है, देन आता है हमारा डिजाइन ऑफ एक्सपेरिमेंट्स। ओके, क्योंकि ये वाला बहुत ही इंपॉर्टेंट रहेगा आपके एमएससी, अगर आप जाएंगे एमएससी पीएचडी में तो डिजाइन ऑफ एक्सपेरिमेंट का सारा जो प्रिंसिपल से आपको आना चाहिए। ठीक है, तो यहाँ पे बहुत स्मॉल चीज है। फॉर एग्जाम्पल वन इज ट्रीटमेंट है, वन इज एक्सपेरिमेंटल यूनिट है, एक्सपेरिमेंटल एरर है। ट्रीटमेंट मतलब क्या है? इट इज द ऑब्जेक्ट्स ऑफ कंपैरिजन इन एन एक्सपेरिमेंट आर कॉल्ड एज ट्रीटमेंट। फॉर एग्जाम्पल I have 5 treatments. For example, 5 treatments of nitrogen levels: 5 kg, 10 kg, 15, 20, 25. So 5 levels of nitrogen. They are called as treatment. Means I want to compare what is the effect of those 5 treatments on the yield of the rice or paddy or rice or wheat, I can tell. Okay. Example, varieties tried in a trial or different chemicals. Okay. Experimental unit, the object to which treatments are applied or basic objects on which the experiment is conducted is known as experimental unit. I can take it is in field, I can take it in greenhouse gases, or I can take in lab experiment as well. Okay, उसको हम बोलेंगे experimental in a piece of land, an animal. Okay, animal में भी हम कर सकते हैं. ठीक है. Experimental error. Okay, a response from all experimental units receiving the same treatment may not be the same even under similar condition. So there will be some other factor that will be affecting the informed treatments, and from that reason there should be variation. Okay, there will be some error. So other factors like heterogeneity of soil, climate factor, genetic difference, etc. also may cause variation. They are called as extraneous extraneous factors. So the variation in response caused by external factor are known as experimental error. हम भी गलत कर सकते हैं. ठीक है. Human error also occur. Then what are the basic principles of design of experiment? There are 3 basic principles. One is replication, randomization, and local control. Replication मतलब क्या है? Same unit को, same block को duplicate करना. Okay? वहाँ पे 3 block लगाए, यहाँ पे भी 3 block, वहाँ पे भी 3 block. Okay? So duplication of the treatments are called as replication. Randomization मतलब when in experimental we will put the samples in a random manner. Okay, we have to put the treatment in random manner, not in the sequence manner. For example, I have 5 treatments. Okay, 5 treatments, 5, 10, 15, 20 and 25 kg. Okay, so I will make 3 blocks of 3 replication. Okay, so I have 5 treatments. Yes or no? 3, 4 and 5. 5 ऐसे करके. Okay, so for example I kept here treatment number 1. Okay, so I'll do 3 sequences 1 2 3 4 5, but here I have to do randomization 5 1 2 4 5 ऐसे I have to do randomization. I have to put the treatments in a random manner in the plot. Okay, that is called as randomization. Okay, when all the treatments have an equal chance of being allocated to different experiment, it is known as randomization. Okay, then आता है हमारा local control. Why use local control in 2021 net exam? It is the question came from local control. So देखिए यहाँ पे एक ब्लॉक है मेरा. ओके, ए ब्लॉक, उसके बाद एक है हमारा बी ब्लॉक. ठीक है, तो whatever the components are there, so when I want to maintain the homogeneity, okay, when I want to maintain the homogeneity within the block, there I will use local control, because basic principle why use to maintain the homogeneity, you should remember this. Okay, why use to do replication, randomization? Because to reduce the errors. Okay, जितना error कम होगा उतना ही हमारा जो experiment है उतना significant आएगा. अगर एरर बहुत ही ज्यादा होगा तो क्या होगा? सिग्निफिकेंट वो कम हो जाएगा. ठीक है, सो more observation or more replication, the significance will be, or the precision of the experiment will be improved. Okay, so for that reason, to reduce the experimental error only, we need to do all these things. Okay, the experimental error is based on the variations from experimental unit to experimental unit. Okay, यहाँ पे एक experimental unit है, यहाँ पे the variation may vary from experimental unit to unit. This suggests that if we group the homogeneous experiments into block, okay, जब हम homogeneous experiment को एक block में हम कर लेंगे, the experimental error will be reduced considerably. So grouping of homogeneous experiment into blocks is known as local control of error. Okay, बहुत बार पूछा गया example है. And in between the block there will be heterogeneity. Okay, heterogeneity within the block, homogeneity, in between the block, heterogeneity. This is also most important. So these things are like a replication, randomization, local control. Among these, replication and randomization are called as estimation. Okay, these are estimation of error. And control of error is blocking, proper plot technique and data analysis are coming under control of error. Okay, sometimes the question may come, what is control of error and estimating of error? So I have given this thing. Then our last thing is the designs. Okay, ANOVA, we are using the ANOVA. Okay, when there will be more than 2 mean. Okay, remember, when there will be more than 2 mean, we are using ANOVA. When there will be less than 2 mean, we are using TTest or JTest. Okay, so when there will be more than 2 mean, we are using ANOVA, analysis of variance. Okay, so it was given by R.F. Fisher. Okay, the father of statistics, R.F. Fisher, उन्होंने दिया था ANOVA का, and calculation of total variance and partitioning into different sources. Okay, जब हम एक एक्सपेरिमेंट में डिफरेंट का जो वेरिएशन होगा उसको अगर हम कैलकुलेट करते हैं टोटल में, तो उसका हम बोलते हैं ANOVA एंड देयर विल बी मोर देन 2 मीन. ओके, सो ज्यादा से ज्यादा मीन, अगर 2 मीन है तो ज्यादा ज्यादा वेरिएंस भी पाए जाएंगे. ठीक है, एंड CRD कंप्लीटली रेंडमाइज्ड डिजाइन होता है. अगर देखा जाए तो मोटा मोटी में 4 डिजाइन बहुत ही इंपॉर्टेंट होता है, CRD, RBD, लोकल कंट्रोल, स्प्लिट और स्ट्रिप. ओके, then CRD मतलब completely randomized design. First, this method where we are using, you should understand this. So this method we are using in lab condition. Where we are using lab condition. So in lab condition, there is no restriction on randomization. Okay, there is no restriction on randomization. There is lack of local control. Okay, because when in lab condition, when we'll do lab condition, so the homogeneity will be very high. The homogeneity will be very high. So we should not use local control here. Okay, there is not applied. So question may come, local control is not used in which design? CRD. Okay, used for lab experiment, animal husbandry experiment and greenhouse experiment. And when there is a limited and scarce available of test material, there you are using CRD, and degree of freedom formula is A, B minus 1. A into B minus 1 is the formula of CRD. Okay, degree of freedom. Next is RBD, a randomized block design. Error degree of freedom should be 12. Okay, उससे ज़्यादा, इससे कम नहीं हो सकता. Okay, 12 आपको चाहिए. For example, ग्रुप ने क्वेश्चन पूछा था. Okay, अगर treatment is 5, then what is the replication? ऐसे कुछ क्वेश्चन आया था. Okay, I think the answer is 4. Okay, मतलब ये माइनस कर देंगे तो ये आएगा 4 और ये माइनस करेंगे 3, तो 4 into 3 is 12. The minimum degree of error degree of freedom should be 12. देख लीजिए, and it works only up to 20 treatments. Okay, 20 से ज्यादा नहीं होगा. Okay, 20 से ज्यादा नहीं होगा. Degree of freedom is A minus 1 into B minus 1. Correction factor अगर आपको कैलकुलेट करना है, grand total square divided by RT or number of total observation. CD is critical difference. The formula is √2 standard error of mean into T table value. Okay, standard error of mean हमने बताया why use standard error of mean, because it is sample mean. Okay, it is sample mean and it will represent the parent population. ठीक है, then standard error of mean formula क्या है? √over EMSS, मतलब error mean sum of square divided by R. Okay, this is the general formula of standard error of mean. ठीक है, then latent square design. Okay, ये कहाँ पे यूज होता है? जहाँ पे एरर इज वेरी लेस होता है. मतलब ये डिजाइन में दो जो फर्टिलिटी ग्रेडियंट होता है, वन इज रो एंड वन इज कॉलम. ठीक है, ये सॉरी ये रो है, ये कॉलम है. ठीक है, ओके, जहाँ पे 2 फर्टिलिटी ग्रेडियंट है फील्ड में, तो वहां पे हम यूज करेंगे लैटिस स्क्वायर डिजाइन. ट्रीटमेंट कितना है? मिनिमम 5 to 8 एंड मैक्सिमम अप टू 12. ये सर आपको याद रखना है. एंड नंबर ऑफ ट्रीटमेंट्स इज इक्वल टू नंबर ऑफ रेप्लिकेशन. सो एरर डिग्री ऑफ फ्रीडम इज T minus 1 into T minus 2. Okay, T minus 1 into T minus. अगर देखिए यहाँ पे ट्रीटमेंट है एंड रेप्लिकेशन भी सेम ही है, तो हम दो एरर हम मतलब अटेम्प्ट कर सकते हैं. ठीक है, दोहरा हम अटेम्प्ट करेंगे, तो इसलिए T minus 2. Fertility variation in the field is in 2 direction of right angle. Okay, at right angle 2 fertility direction है. ठीक है, then split plot design when the number of treatments is more than 20, वहां पे हम split plot यूज करते हैं. Factors require different plot size, जहाँ पे एक small size का plot चाहिए और large size का plot चाहिए और different size of plot size चाहिए, तो वहां पे हम स्प्लिट प्लॉट डिजाइन यूज करते हैं। लार्जर प्लॉट में क्या क्या हम ले सकते हैं, टिलेज ऑपरेशन, इरिगेशन, डेट ऑफ सोइंग, एंड स्मॉल प्लॉट में फर्टिलाइजर डोज, सोइंग डेप्थ ऐसे यूज करते हैं। और हायर प्रिसिशन, अगर किसी एक्सपेरिमेंट में फॉर एग्जांपल आई वांट व्हाट इज द इफेक्ट ऑफ फर्टिलाइजर, तो इसका हमारा इसका अगर हम चाहेंगे कि इसका प्रिसिशन बहुत ही ज्यादा हो तो इसको हम सब प्लॉट में डालेंगे। तो क्वेश्चन आता है कि टू नो if you want to know the higher precision of any value, then in split plot design where we will keep the treatment, we will keep the treatment in subplot, then only we will get the higher precision. ठीक है। then degree of freedom वाला एक वाला क्वेश्चन आता है, the error degree of freedom of main plot, okay, error degree of freedom main plot is r-1 into a-1। अगर सिर्फ degree of freedom पूछा गया main plot का, then a-1। अगर degree of freedom for replication पूछा गया तो r-1, देन सब प्लॉट का b-1, और अगर इंटरेक्शन का पूछा गया मेन प्लॉट एंड सब प्लॉट, देन a-1 इंटू b-1। अगर एरर डिग्री ऑफ फ्रीडम फॉर सब प्लॉट पूछा गया, मतलब पूरा का पूरा पूछा गया, देन a इंटू r-1 इंटू b-1। सो व्हेन द क्वेश्चन विल कम, वी हैव टू रीड द क्वेश्चन प्रॉपर्ली। क्या पूछा गया है, क्या आपको एरर डिग्री ऑफ फ्रीडम ऑफ मेन प्लॉट पूछा गया तो r-1 इंटू a-1 करना। अगर आपको एरर डिग्री ऑफ फ्रीडम ऑफ सब प्लॉट पूछा गया देन a इंटू r-1 इंटू b- करना। अगर आपको डिग्री ऑफ फ्रीडम ऑफ इंटरेक्शन पूछा गया तो a-1 इंटू b-1 करना। ठीक है। सिर्फ आपको एरर डिग्री ऑफ सिर्फ आपको डिग्री ऑफ फ्रीडम ऑफ मेन प्लॉट पूछा गया देन a-1 करना है। बहुत ही कंफ्यूजिंग है। देन स्टैंडर्ड एरर ऑफ मीन क्या होगा, रूट ओवर एरर ऑफ मीन सम स्क्वायर ऑफ मेन प्लॉट डिवाइड r इंटू b, मतलब b सब प्लॉट। अगर ये मेन प्लॉट का है, अगर सब प्लॉट का पूछा गया एरर ऑफ मीन ऑफ सम b डिवाइड बाय r इंटू a। ओके, यू कैन एक्सचेंज इट। देन आता है हमारा स्ट्रिप प्लॉट। स्ट्रिप प्लॉट मतलब क्या है, अगर दो एक्सपेरिमेंट लार्ज प्लॉट ही चाहिए, सबको लार्ज वाला प्लॉट है, यहाँ पे स्मॉल का कॉन्सेप्ट नहीं है, यहाँ पे सबको लार्ज प्लॉट चाहिए तो हम यूज कर सकते हैं स्ट्रिप प्लॉट। इट इज सुइटेबल व्हेन बोथ द फैक्टर्स रिक्वायर लार्जर प्लॉट साइज। ओके, जहाँ पे दोनों को लार्जर प्लॉट साइज की जरूरत है वहां पे हम यूज कर सकते हैं ये वाला। ठीक है। एंड इंटरेक्शन इफेक्ट इज एस्टिमेटेड विद हायर प्रिसिशन। ओके, हायर प्रिसिशन में हम यहाँ पे इंटरेक्शन पे जान पाएंगे। तो एक क्वेश्चन आता है, ओके, इंटरेक्शन इफेक्ट, ओके, किस डिजाइन में हायर प्रिसिशन में हम जान पाएंगे, तो आंसर इज स्ट्रिप प्लॉट डिजाइन। ठीक है। और यहाँ पे भी सेम फॉर्मूला है ऑलमोस्ट। ओके, एंड एरर डिग्री ऑफ फ्रीडम ऑफ सी, ओके, इज r-1, a-1 एंड b-, ये वाला आपको फॉर्मूला याद रखना है, बहुत ही इंपॉर्टेंट है। ठीक है। और कभी कभी या ये वाला भी पूछा जाता है, जो एफ जो कैलकुलेटेबल होता है, ये देखिए डिवाइड ही होता है। ठीक है, RMS डिवाइड बाई EMS, जो हमारा जो एरर मीन सम स्क्वायर आएगा, तो रेप्लिकेशन मीन सम स्क्वायर डिवाइड बाई EMS विल गिव यू द एफ calculated value. Then main plot का AMS divided by EMS will give you the F calculated value of main plot. ठीक है। जब F calculated value will be greater than F table value, then it is significant, and if it is less than, then it is non-significant. ठीक है। ये वाला भी कभी कभी पूछा जाता है, मीन सम स्क्वायर का पूछा जाता है, सम स्क्वायर तो ये तो नहीं पूछा गया, मीन सम स्क्वायर पूछा जाता है। एंड देखिए जो ये और ये वाला बहुत बार पूछा गया है। ठीक है, एफ कैलकुलेट वैल्यू कैसे कैलकुलेट, आपको दे देंगे RMS एंड EMS दे देंगे, देन यू हैव टू कैलकुलेट द एफ कैलकुलेटेड वैल्यू। ठीक है, दैट्स ऑल फॉर टुडेस क्लास। स्टैटिस्टिक्स खत्म। कोई डाउट है तो पूछ लीजिएगा अभी, क्योंकि बाद में थोड़ा लेट हो सकता है क्योंकि एग्जाम इज ऑन 9th। कोई डाउट है आपका, पूछ लो अभी। एनी डाउट? कोई है या नहीं क्लास में? ओके, उतना ही है। एनी डाउट गाइस? राजेश, कोई डाउट है स्टैटिस्टिक्स में अभी?
No, sir.
समझ में आया? आई थिंक यू केम लेट।
Yes, sir.
ओके, नो प्रॉब्लम। मेघना, कोई डाउट है?
Sir, 1 and 2 till test.
Okay, one tail test and two tail test, right?
Yes.
Okay, see क्या होता है, देखिए तो ये मेरा see I have two samples A and B, ठीक है? तो when I will calculate the mean, I will get mu1 and mu2. Okay, so for example, mu1 is not equal to mu2, so there is I cannot the difference the where it will fall. Okay, the critical region I cannot decide here. Okay, so it can fall in any of the region. Okay, if mu1 is greater than mu2, so I can know that mu1 is greater than mu2, so it is showing a direction towards the A. So my next will be when I'll take the distribution. Okay, so it may fall in which side? Which side will fall? It will fall in the left side. Okay, when mu1 is less than mu2, it is showing that mu2 is greater than the mu1, so it may fall in the right side. Okay, so this thing, when this condition be appear, then one tail test, this is one tail test, this is one tail, and this is two tail test. Okay, it may fall either of the region, it may fall right or it may fall left. Okay, so this is called two tail test. समझ में आया?
Yes, sir.
Okay, anything else? राणा दुबे?
सर
या बोलिए. हेलो, राणा बोलिए.
सर स्लाइड का पीडीएफ चाहिए था इस वाली.
या ये तो हम डाल देंगे ना नोट वेबसाइट में. हर एक हम जो भी पढ़ा रहे हैं उसका नोट वो वेबसाइट में अवेलेबल है. ओके, डाउनलोड कर सकते हैं. ठीक है,
ओके सर.
ठीक. प्रत्याशा आपको समझ में आया? प्रत्याशा, आर यू देयर? डिड यू गेट दिस कॉन्सेप्ट्स?
Yes, sir.
डाउट है तो यू कैन आस्क मी लेटर ऑन. ओके, विल डिस्कस. ओके,
Okay.